So this was the second method of preparation of alkene. Now let's move to the next method of preparation of alkene, which is somewhat similar to the present method, and this would be called as dehalogenation. Now previous method was dehydrohalogenation, in which both hydrogen and halogen was abstracted. Now this one is dehalogenation, and from the name you can guess that only halogen will be removed off from the substrate. Suppose this is halogen and X can be chlorine or bromine or iodine. Now if I add zinc to this substrate, I get a alkene and ZnCl2 or X2, whatever the halogen is. Now let's see the mechanism, or intuitively you can start guessing the mechanism, because we have studied enough of the reactions, and looking at the reagent you know which reagent does what. So intuitively you can start guessing the mechanism as well, and after a few reactions you will very convincingly start to predict the mechanism of any of the reactions that we would be studying later on. So this you have to start getting your bones straight, and you have to start using your mind so that things starts to become clear and clear, and with conviction you can predict the mechanism, because things would be simple, same thing would come over and over again. So the thing is, this is a neutral molecule and this is a metal, and in such cases metal is the one which initiates the reaction, because metal is more reactive. This neutral organic compound is not reactive because neither it has charge nor it is electron rich. There's no way it can initiate a reaction. Zinc will initiate the reaction. Zinc will lose electron. Zinc loses two electrons to get a pseudo noble gas configuration. Zinc will lose 2 electrons, and those 2 electrons, as we have been doing up till now, again we will do the same thing. These 2 electrons will have to go in someone's orbital, bonding orbital or anti-bonding orbital. Here the octet of all the atoms are complete, or the duplet of all the atoms are complete. So this electron will not be gained by any other atom in bonding orbital, because the bonding orbital of all the atom are complete. Now in this circumstance we know that this electron will have to go into the anti-bonding orbital of any leaving group, and halogens are good leaving group. We know that because halogens have higher electronegativity value and size, so they can take the negative charge very well. So this is the anti-bonding orbital of the carbon which is attached to halogen. Here I have taken a symmetrical case, so you don't have to use much of your mind to decide on as to which carbon will gain these 2 electrons. Just to emphasize upon the mechanism, I am using a simple case. When we solve a problem, we will use all kind of cases possible. Here, in any of the carbon, this electron will go. So these 2 electrons went into the anti-bonding orbital of this carbon. Now anti-bonding orbital and bonding orbital together can hold at max of 2 electrons, as I have told you before. Now when the electronic density in anti-bonding orbital increases, the electronic density from bonding orbital have to decrease. Right, so the electronic density from bonding orbital will start to come out, and it would go into the orbital of this halogen, bonding orbital of this halogen. So what would happen is, when 2 electrons goes into this anti-bonding, the 2 electron of this bond which was in the bonding orbital will come out, and those 2 electrons will go into the bonding orbital of this X. So if I show you this sporadic event, if I show you this event sporadically, although it will happen continuously, suppose this happened, these 2 electrons went into the anti-bonding orbital, the 2 electrons from the front will come out and go into the bonding orbital of this X. So this X will come out as X minus, and this C will gain those 2 electrons, first from C dot and next from C minus. I have shown you like this, right? Now what would happen simultaneously, although I have shown that X minus comes out, but what would happen simultaneously is, there is also a carbon beside this carbon gaining charge, which is also bonded to this leaving group, and Simultaneously, what will happen, this electronic density of this carbon will get transferred into the antibonding of this carbon, because this carbon by no way is capable of holding that negative charge effectively. A, because the electronegativity value of carbon is least, and B, because size of the carbon is small. So electronic density becomes high. So carbon becomes unstable. So for that reason, the electronic density of this carbon will come out and will go into the orbital of carbon, adjacent carbon. Now this is happening only because this carbon is also attached to a leaving group, so that when the electronic density of this carbon comes out, this carbon will come out of certain amount of strain because of that negative charge. So this carbon will be relieved. But when this carbon starts to gain negative charge, now this carbon will start to come under stress. So this carbon also has to have a mechanism to relieve itself from that strain of negative charge. And it does have a mechanism. What it does, from the front side, it loses electron into the orbital of this X minus, this halogen. And this X minus, this X is happy to come out as X minus because it is capable of holding that negative charge, because it will have higher electronegativity value and higher size. Right? So then what would happen is, this orbital has 2 electrons. One of the electronic density corresponding to 1 electron will come out into this orbital, and this carbon will lose these 2 electrons, and this X minus will come out. Right? When it loses 2 electrons, it becomes deficient of 2 electrons. When the first electron comes in, it becomes C dot, from C plus to C dot. Now this C is existing as C minus. When 1 electron comes out, it also becomes C dot, and this C dot and this C dot will form a pi bond and form a C double bond. Right? So I'm showing it as 2-step process just for the sake of understanding, but the whole phenomena will be occurring simultaneously. So a bond will be formed between this C and this C. So we will have CS2 double bond CS2. This X minus will also comes out, and this zinc has become divalent Zn plus 2. So I'm writing it as ZnX2. So this is something which you can predict, because this is something happening over and over again. This is the same phenomena we had in case of dehydrohallucination. This is the same thing will happen in many other reactions. So this is what happens. Electrons go into antibonding, leaving group comes out. If there's a possibility of that electron moving into adjacent orbital, it does happen so. Right? So this is what it is. This is dehalogenation, because halogen has been removed from the substrate, resulting in formation of alkene. Now you have to remember that you can't take other metals like sodium or magnesium or calcium for that matter. You have to take zinc. A, because zinc is reactive, rate of reaction would be considerable, and B, zinc doesn't have tendency of forming complex, as I have explained you before when I taught you Wood's reaction. So if you take sodium, other reaction will occur. If you take magnesium, Grignard reagent will be formed. If you take potassium, again similar kind of Wood's reaction will occur. So this reaction will occur only by zinc and no other metals as such. So this is our third method of preparation for alkene.